centroid of an area. The centroid of an area is analogous to the center of gravity of a homogeneous body. The location of the centroid of an area, bounded by the x and y axes, and the function y is equals to f, or the function of x, can be found by integration using the following equations. A sub t, or the total area, times the centroid along x is equal to the integration of x differential of a, or a t, or the area total, times y sub c, or the centroid along y, is equal to the integration of y, the distance y, times the differential of area. Centroid of plane area. The centroid of a complex area can be found by dividing the area into basic shapes: rectangle, triangles, circles, or any other shapes. And for this diagram, we can divide into three different areas. First, area 1, and the shape is a rectangle. Area 2 is also a rectangle, and area 3 is also a small rectangle. Then we find the centroid of the plane area, and for this example or diagram, this is the centroid of the plane area, wherein at the origin on the lower left, 0 or O, the distance from the x-axis is denoted as x sub c, and from the y-axis, y sub c. So we have the point x sub c and y sub c, which is the centroid of the plane area given. Next, moment of area. The moment of area, or designated as I, of an area is a very useful property in mechanics problems. The moment of inertia about the x and y axis and the function y is equals to the function of x can be found by integration. So this is the area, and this is the centroid of the plane area. And along the x-axis, we have the distance d. And for computation, Ix, or the moment of inertia along x, is equal to the centroid, or I gx, the centroid of the given area, plus the area times the distance square from the x-axis to the centroid of the plane area. So this is the formula for moment of inertia. Properties of common geometric shapes. These are formulas generated based on the centroid and moment of inertia. For a triangle with a base b, a height h, and the distance a, to find x sub c is equal to a plus b all over 3, while y sub c is equal to h over 3, which means from this axis going to the centroid and the distance y, and the value is equivalent to 1/3 of h. So y sub c is equals to 1/3 of h. Or if the axis is above the point of this triangle, the y sub c is equivalent to 2/3 of h. From this point going to this maximum point, the distance is 2/3 of h, or in this case, x-axis to the centroid, the distance yc is equal to 1/3 of h. And the area of a triangle is always 1/2 of the base times height. And for the moment of inertia, Ix is equal to the base times height cube all over 12, or bh cube all over 12. The centroid of Igx is equal to BH cubed all over 36. So this is the triangle formula for the centroid and moment of inertia. Next, another geometric shape is a rectangle, and we have the base and the depth, and the centroid is always one half of the base and one half of the depth. So the centroid is always one half and one half of the base. So area for a rectangle is always B times D. And for the moment of inertia along x, I sub x is equal to BD cubed all over 3, while if the moment of inertia along y is the opposite of BD cubed, which is DB cubed all over 3. And the centroid or I based on the gravity of x is equal to BD cubed all over 12, and the gravity I gy is equals to dV cubed all over 12. Another shape is a circle with a radius r, and the diameter is always equal to twice of the radius. And the area for a circle is equal to pi r squared, or in terms of diameter, it is equal to 1/4 pi d squared, or pi over 4 d squared. And the centroid of I gx is also equal to igy, which is equivalent to pi r to the fourth all over 4. In terms of diameter, it is pi d to the fourth all over 64. So you can use this area and the moment of inertia. What about the centroid? The centroid is always at the center of the circle. Next, quarter circle, which means 1/4 of the shaded area of a circle. The area is 1/4. Definitely it's 1/4 of pi r squared, or the area of circle. And x sub c is also equal to y sub c. So x sub c and y sub c are the same value, and it is equivalent to 4r all over 3 pi. While moment of inertia along x and y are the same, which is pi r to the fourth all over 16. And igx is also equal to igy, and it is equal to 0.055 r exponent 4. So these are circle and quarter circle formulas. Semicircle, which means one half of the total area of the circle, or area is equals to one half of pi r squared, where y sub c is equal to 4r over 3 pi. Y sub c is equal to 4r all over 3 pi. And I sub x is equal to I sub gy is equal to pi r to the fourth all over 8, and igx is equal to 0.11 r to the fourth. And the last is ellipse. We have the distance a and distance b along the centroid of the plane area ellipse. And the area for ellipse is always equal to pi ab, while a sub gx is equal to pi ab cubed all over 4, and igy is equal to pi ba cubed all over 4. So interchange a and b and b and a. The longer distance is a, while the shorter distance is b.